Hi everyone. How are you guys doing today? Good. Do you remember what will be next Friday? Your first exam. And I decided the exam will be from 3.6 to 10.2. So 3.6, 8.1, 8.2, 5.1, and 10.2, 5 sections. I'm planning to make a review sheet over the weekend to show you the types of question you expect to see in the exam. The question will actually be similar to the one we do in class. I'll just give you less amount of questions in the exam. Okay, any question before we start? Any comments, concern, complaint? Did you hear that last night Trump was here? Our president was here. In New York. Okay. Yeah. Yeah. The road, the entire Lexington and Paddington, from which state to which state, I don't know. The road was blocked and I was in the middle of the road. So I had to at least 30 to 45 minutes just sitting in the bus doing nothing.
Yeah. Last night on the US Open, and you have like a bunch of people complaining because due to for security reasons, the lines were like huge to get like inside, and you still have like a bunch of people like outside when it started.
And the road, like all the roads are blocked. Only which street was it? 57th Street. I saw only 57th Street. The cars are running on the 57th Street, but no bus was running, nothing. So all the buses, they got stuck one after another. And I was like, most of the bus, they let all their passengers go down and then they put the signal not in service. And then they were standing there. So I was hoping my bus not to do that. And he didn't do that. I was sitting in the bus. Like, oh man, if I knew today's 9/11 that's going to happen, then I wouldn't have done that. I wouldn't have taken bus. But yeah, I went to around 11:30. It was a hassle. Okay, so last night I promised myself no more 9/11. In every 9/11, I'm not going to ride bus anymore. It's a bad idea. It's better to take train than bus. Yeah. Okay, so in our last class, we did simplifying radicals with positive power, negative power, fraction power, positive base, negative base. And we didn't go over this in class because I went over these questions in my morning class. So if you need to see the solution, just watch my morning lecture on YouTube. But I'm going to do a few, for example, C and D. We have a negative power. The direction says simplify, but don't leave any negative power on your result. So at the end, we need to get rid of the negative power. But before that, we have to simplify our what do you call it? Base. We need to simplify the base. Oh no, we need to rewrite the base to simplify the expression. So our goal is to keep our negative to third power, but rewrite the base 8. Do you remember how do you rewrite the base?
Think about what multiply 3 times.
Good. And why 3 times? What's so special about 3?
That's the denominator.
Good job. Our goal is to get you the denominator because we hate denominator. So once you have a new same power as the denominator, you can cancel them. The denominator 3 and the new power 3, and you're left to 2 inside and negative 2 outside. And now we hit the negative power. So how can you get you the negative power? Do you remember?
Turn it into a fraction.
Turn into fraction. What goes in the numerator in the fraction?
1.
1. So it's 1 over 2 to the positive 2 power. And now what is 2 squared? 4. So it's the fraction 1/4. Similarly, the next one, we have double negative. One negative is on the base, one negative is on the numerator, on the power. So we know how to convert the power into negative power into positive, but the negative base, we cannot get rid of that. Instead, we are going to rewrite same as the last one. We keep our negative 2/3 power, and instead of writing negative 64, what do we write? Negative 4 to the power 3. So negative 4 times negative 4 is 16. 16 times negative 4 is negative 64. So we rewrote negative 64 as negative 4 inside the parentheses and the cube power. And the same thing is happening. The 3 on the 3 power, the 3 on the power and 3 on the denominator cancel out. So we left with negative 4 inside the parentheses and negative 2 outside the parentheses on the power. And then what do we do?
Make it
Fraction. So we hit the negative power, we can turn into positive by flipping it, by making it a fraction. And now we have 1 over negative 4 square. What is negative 4 square? Positive 16. Since we are doing this, let me remind you about the difference between negative 4 square and negative 4 square. What's the difference between these two?
in the parentheses, that's the entire base. Right? So if you square that, you get 15.
So multiplying negative 4 and negative 4. So you get positive 16. But what is happening here?
The negative is not really part of the base. You have to multiply it after.
The negative is a multiplication. So it's negative times 4 square. 4 times 4. So if you don't have the negative inside the parentheses, it's not base, it's multiplication. So you have to keep your multiplication and work with the exponent. So we get negative 16 here. So they are not same. Be careful about having a parenthesis and not having a parenthesis. I'm going to skip this too. Let me know when you're done. Ready? Okay. Now this type of question on the right. We have multiple powers, multiple base. So in that case, we work differently. Let me do, see. We have 4x to the negative 3. Everything has the power 3. And on the denominator, we have 6x to the 4. Everything has power negative 2. Since we have numerator and denominator with the individual power, so we have to distribute the individual powers separately. So 3 goes to 4 and 3 goes to x to the negative 3. Similarly, on the bottom, 6 gets the negative 2 power, and also x to the 4 gets the negative 2 power. So we have 4 with the 3 power, x to the negative 3 with the 3 power, and the denominator 6 with the negative 2 power, and x to the 4 with the negative 2 power. So you have to distribute the individual power and then simplify. So we have 2 powers for the variable x. What we do if you have two powers, multiply. So let me do it here. We have 4 cube. 4 cube doesn't have any problem. It's 4 times 4 times 4. What is 4 cube? 64. And then we have x to the what power? Negative 9. On the denominator, 6 has a negative power, so leave it alone. Most people think 6 to the power negative 2 is negative 36, which is definitely wrong. So if you have a negative power, don't touch that. Our goal is to convert all the negative power into positive power and then simplify. So we did 4 cube because 4 cube doesn't have any negative power, so we could do the math easily. But for the other 3 terms, other 3 factors, they all have negative power, so we're not going to touch them. On the denominator, x is what power? Negative 8. Besides 64, everything else has negative power. So in order to erase all the negative power, what do you have to do? Switch all their position. So 6 is the negative, bring it up, it will become positive. X to the 9 has a negative, move it down, it will become positive. X to the 8 has a negative, move it up, it will become positive. So switch them around. And then you rewrite. Currently we have 64 without any problem, we keep it. And 6 to the negative 2, we bring it on the top and it becomes 6 to the positive 2. Then for the variable, x to the negative 9 goes on the denominator, it becomes x to the positive 9. X to the negative 8 goes on the top, and it becomes positive 8. So switch them around, they become positive. You don't have to write as a fraction because we already have a fraction. When you already have a fraction, just switch them around. And now we can simplify. For the variable, we have a division. In division, what do you do? Subtract. So we have x to the 9 on the bottom, and we subtract the 8 from the top, so we get x to the 1. But 1 is invisible. If you don't want to have to. And on the numerator, we have 64 times 6 squared. What is 6 squared? 36. And then you're going to multiply that without using calculator. So let me do it here. 64 times 36. If you forgot your manual multiplication, you have to review that. But let me refresh your memory. First, we start with the right side. We multiply the two right numbers. 6 times 4. What is 6 times 4? 24. 24 is two numbers. We cannot put two numbers at the same time. So we put the right number on the bottom and we put the left number on the top as an addition. And then we multiply other one. 6 times 6. What is 6 times 6? Plus that extra 2. 38. So that's the first line multiplication. Then, since we are going to start the second position, the 10th place, so we have to leave the first place blank. 3 is on the 10th place, so we are going to leave the first place as empty, and we put 0 as a placeholder in there. And we do the same multiplication again. 3 times 4, 12. So 12 is two numbers, we cannot write them together. We put 2 on the bottom, and we put 1 on the top as an addition. And then you multiply 3 times 6 plus that one, 19. And then at the end, we add them together. 4 plus 0 is 4. 8 plus 2, 10. Again, 10 is two numbers, you cannot put them together. So you put 0 here and 1 on the top as an addition. The next number, we have 9 plus 3 plus that one, 13. So 13, two numbers, again, you cannot do that. So you put 3 on the bottom and you put 1 as an addition. And then on the last row, on the last column, we have 1 plus that extra 1. So it's 2. So on the numerator, we have a big number, 2304, and the denominator, we have only x. That's our final answer. And these are final exam questions. You are going to see at least one of them in the final. And also this type of question. See here, all these we did. You're going to see them in the final exam. Definitely also in the in-class exam, but also in the final exam. Any question? Comments? Complaints so far? No? Okay. So now we are going to begin today's lecture. We're going to learn new stuff, but the new stuff is built on the old stuff. We are going to apply the multiplication rule. So here we have x to the 1/3 times x to the 2/3. In multiplication, what do you do with the powers? Add them. So we keep our base x, but we add the two powers. It doesn't matter what type of power you have. You may have whole number power, you may have fraction or decimal. You can have any power, doesn't matter. The rule says when you're multiplying the bases, if you have the same base, you must add the powers. So we have 1/3 plus 2/3 on the power. So what is 1/3 plus 2/3? 3/3. And what is 3/3? 1. In other words, we have x to the 1, but 1 is invisible. So it's simply x. And here, never mind. You may have positive power, you may have negative power. It doesn't matter. The rule is same. So what do we do in the next one for the b base? So we have b to the negative 49 plus 29. What do you get from the addition? Negative 29. So we have b to the negative 29, but we cannot have the negative power. So we have to make it a fraction. 1 over b to the positive 29. Any question? So in this two example, you have the same denominator. So we didn't have any problem. We added the numerator directly. But our life will not be so easy all the time. For example, the next one. We have y to the 49, and you're multiplying y to the 2/5. At least we know how to start, right? What do you do? Y to the plus 2/5. And now we have a problem. We don't have the same denominator. So what do you do? So what's the common denominator between 5 and 9? 45. Since they don't have anything common, 5 and 9, they cannot multiply 5 by something, it becomes 9. It's not possible. When you have this scenario, then you multiply both of them, and that's the LCD. So 5 times 9 is 45. We want 45 under both both denominator. So that 9, we have to multiply by 1 to turn this into 45. 5. But math is fair. Math says if you multiply the denominator, you also have to give me one, same 5. So you multiply the numerator. Similarly, we need to multiply 5 by what? 9. So you multiply both top and bottom. And now we are happy both denominators have same 45. So we write the 45 once and we add the numerators. What do we get on the first numerator? 20. And we are adding how much? 18. So it is 20 plus 18. 38 and 45. Can you reduce them anyhow? 38 and 45. No. So leave it alone. Anytime you can reduce something, you reduce, but if you cannot reduce, you have to leave it alone. So same denominator, different denominator, whole number, fraction doesn't matter. You just have to add in multiplication. Then how about the division? What do you do in the division? If you divide the same base, what do you do with the powers? Subtract. So do you remember the rules from before? What is, let me restart my word. Okay, the exponent rules I showed you before. If you have square root, come on. Okay. If you have square root of x, it becomes x to the what power? As a 1/2. It becomes fraction. So if you have cube root of x, it becomes what power? X to the 1/3. And if you have, let's say, cube root of x to the 4, so 4 goes in the numerator instead of 1, and then we have 3 on the denominator. So these are the exponent rules. So now we have this question. 5th root of x cubed and 6th root of x. So before even trying to combine them, first we need to see the exponent as a power, not as a radical. So we have to rewrite. So what do we get on the numerator? X to the what?
3, 5.
3 on the top, 5 on the bottom, because 5 is the denominator from the radical. How about the denominator? 1/6. And now this looks familiar. We have numbers instead of radicals. So we go and do the division rule. In division, we subtract the power, right? And we subtract the smaller power from the bigger one. So can you identify which one is bigger, 3/5 or 1/6? If you can identify, it's good for you. If you cannot, then it's okay. Try in either way. And if you get a negative power, you get just make it as a fraction. But here, yep, he's correct. 3/5 is bigger than 1/6. So we keep our 3/5 and we subtract the 1/6. Oops, come on. 1/6 from the denominator. And now it becomes the same question what we did before. We don't have the same denominator, so we need to have our LCD. What's the LCD between 5 and 6? 30. So I need to multiply 5 by 6 and 6 by 5. So what do we get on the numerator? And the second numerator? 5 times 1. So what do we get at the end? 13/30. So x to the 13/30. I have no problem with this, but I noticed my MATLAB doesn't like this. My method says, don't keep fraction power, rewrite as a radical. Means if you have this, give my method that format. So how are you going to rewrite this using a radical? What goes inside the radical symbol? How much? Inside that whole, inside that V goes 30, and on the X as a power, 13. This is what my method wants. My method.
So it means for this test, plus the first format.
Fraction is forward. Question? No. Okay. Next. Now this time, then I should write down the direction. Simplify. So in the direction for the last few questions was multiply or divide and then simplify. And this one is only simplify because we have no multiplication or division to do here. So they gave us the final result and they want us to simplify that. There's a difference between the question, the couple of questions we did and this one. Can you identify the difference? Two variable. So all these examples we did so far in the new lecture, they had only one variable to work with, either X or Y or B. But here they gave us both variables together at the same time under the same roof. So when you simplify, we have to separate them. So we write 12. So this is the rule for this one. Remember the exponent rule? If you have multiple bases, what do you do with the power? Distribute. So you get x to the n, y to the n. That n could be anything. Could be whole number, could be fraction, could be decimal. So here we have a radical. Radical applies the same thing. If you have a square root of xy, in multiplication, it means square root of x times square root of y. If you have x divided by y under the square root, it means square root of x divided by square root of y. And radical is a fraction. It's a, sorry, radical is a power. It's a fraction power. So that's how we can separate them. So we are going to separate both a and b. We write a to the 9 under 1 12 root and b cube under another 12 root. So we separate the variables because our goal is to solve each one of them separately. And then we rewrite. For a, what do you have? What over what? 9 over 12. And for b, what do you get? 3 over 12. Can you simplify them? 9 and 12, both of them are divisible by something, right? 3. So what do you get? What over what? 3 over 4. And 3 and 12, both are divisible by 3. So we get 1/4. So in other words, we have a to the 3/4 and b to the 1/4. Well, for paper, it doesn't, it's okay. But my method is strict. She said, no, I don't like this. Combine them under one radical. So we have to rewrite using this format. So we have a and b under radical. Now what goes that inside v radical, the v? B of the radical? Good, 4. And now A and B, what power they have? A has a 3 power and B has 1 power. 1 is invisible. If you don't want, you don't have to write it. This is my method preference. And that's how we simplify variable. When we have multiple variables, we divide them. And here we cannot divide completely because we have a fraction, but sometimes we can divide completely. And sometimes we cannot divide completely, we get a remainder left. So we are going to learn all these things today. Any question on this question? Was anything unclear, confusing? Okay. Okay, so in these few examples, if you notice, we have different denominators. We have 5 and 6 different denominators. Also here, this one is same, but there's one more here, 9 and 5, different denominators. So when you have different denominators, you still can combine them by having the same LCD. Now the examples we are going to do now, they have the same radical, means same denominator. And we are going to multiply different types of things. For example, numbers, variables, all this together. But one good thing is that we are going to multiply them under the same radical. So when we have same radical, you're multiplying, you keep the radical and you separate your whatever you have. For example, here we have numbers and variable. So we are allowed to multiply them under the radical, but we have to do it separately. Just like the example we did A and B, we separated them. So here we are going to separate them. We are going to put numbers under one variable and variables under another variable. So as long as the variables are, as long as we have a positive radicand, so let me refresh your memory. Whatever we have inside, we call them radicand, and whatever we have on the root, we call them index. They have other names also, okay? But so the index, as long as you have the same index and your radicands are positive, then you're allowed to multiply them. For example, if we have square root of 2 and square root of 3, you're allowed to multiply 2 and 3 because they have the same index square. So you get square root of 6. Or if you have square root of x times square root of y, or let's say cube root of x and cube root of y, we have the same index cube, so we multiply x and y by assuming they're positive. So cube root of xy. So the rule, as long as you have the same index, it doesn't matter what you have inside your radical, as long as they're positive, you're allowed to multiply them. However, if they're negative, you cannot multiply them. For example, if we have square root of 2 and square root of -2, you cannot multiply them. First, you have to make this negative into a real number, and then you can multiply them. We're going to learn that in 10.7, but I'm just telling you, when you have a positive inside, you're allowed to multiply. When you have a negative inside, you cannot multiply until you take out your negative and turn the inside into positive something. But anyway, in our case, we assume both x's are positive, so we don't have any problem. We multiply 25 and 10 under one radical, and we multiply x to the 5 and x to the 8 under another radical. Because we need to combine the numbers and combine the variables. Now let's do the variable first. We have cube root. In multiplication, how do you combine the powers? Add them. So we have x to the how much? 13. And then in order to simplify, we need to rewrite x to the what over what? 13/3. And we cannot reduce them anyhow. So we have to actually divide them. 3 goes to 13 how many times? 4 times. And this time we have a remainder. How much is our remainder? 1. 1 is the remainder, 3 is the denominator. So when we divide 13 by 3, we cannot divide 13 by 3 evenly, but we can divide at least 4 times evenly, and then we have something extra, one thing extra. So for each one of them, we get their bases, their own bases. We put x to the 4 and x to the 1, because these are the part on the x. And then since 4, we got the 4 by dividing evenly, so it becomes 3. We could divide it evenly, but we get the 1 as a remainder. Whatever we have remainder, that goes back inside whatever we have on the radical. So you have a cube root, it has to go back inside the cube root. And that's how we reduce variable, simplify variable. For number, the scenario is different. But let me give you 1 second to digest the information. For number, we are looking for same number radical many times. So you want to see, do we have the same number inside 25 times 10? So you can multiply 25 times 10, but it doesn't help you. Instead, factor them into prime factorization. Means split them into pieces until you get your prime factors. So 25 is what two numbers? 5 times 5. And now 10 is what two numbers? 5 times 2. So 25 times 10 is 5 times 5 times 5 times 2. Now, do you see the same number 3 times? What number is it 3 times? 5. So you put them together under one radical because we want them together. So 5 3 times goes inside one cube root, and we have a remainder just like the remainder 1. That remainder goes back inside alone. But there's a good thing about that. When we have cube root of 5 cube, what happens to the cube root and cube power? Cancel out. They hate each other so much that they kill one another. So no more radical. What is left then? Just the 5. So now 5 is free. Its parents die, so he's floating now everywhere. But the 2 is still young. It has to stay inside the house. So we simplified variable to get separately and number separately. By then, we cannot leave them separately. It's time for them to get back together. Can you guess which two we put them together? The adult goes with adult. So 5 is an adult and x to the 4 is an adult. We put them together. And we have 2 children. One is the number, one is the variable. So we put the children inside the house together. And that is our final answer. My favorite it is. So let me read box. Any question? Was anything hard, confusing?
Why is it 2x?
Inside one house, we have 2, the child. Inside another house, we have X, the child. So you put the child together and they're playing with each other. And we have 2 adults, they are talking with one another. That's how life is, right? When guests come over, usually the adults don't hang out with the kids. The kids hang out with kids, and adults talk with adults, right? That's how our real life is. Same thing, the math. Adults goes with adults. Okay, the next one. Try it for 2 minutes. The same concept. Multiply, simplify. Oh, I forgot to put this. Today is 9/12. Ashley, Jelisa, Michael, Letty, Lola, Jonathan, Reina, Ali, not here. Denisa, Samantha, Nicole, Andy, Priya, Caitlin, Hack, Andrew, George, Mariana, Danielle, Fatumata, Azmain, Shuing, Chloe, Ethan, Kathleen, Brennan, Raim, Chahana, Leonardo, Brian, Brian R, Brian V. Oh, thank you. Gian, How? Come on. Alex, Anastasia. Okay, ready, guys? Any volunteer? Go ahead, Daniel.
First, I did with the numbers.
9 times 9.
And instead of splitting it up, I just did cube root 81.
What is cube root of 81? No. Of course not. Exactly. That's I told you. Multiplying will not help you. So split it. How do you get? 3 times 3. 3 times 3. So what are you looking for? Same number how many times? You're looking for 3 times. You have 4 times, but you're looking for same number 3 times. So you put 3 together 3 times, but you have something extra. Do you have extra in your math? You do? No, on the paper. The paper you did. You don't have the extra 3, right? See? That's why don't multiply, just split it because you need to see what do you have. 4th root of 81 is 3, not cube root. That's a common mistake. Okay, then what happens?
And x to 5 times x.
But you're not done simplifying, right?
Yeah.
What happens to the cube root and cube power?
So 3 to the third power, you have 3 on the outside, and on the inside.
Another 3. There are so many 3's here. 3, 3, 3. Yeah. Okay, so number is done. It's simplified number completely. Now the variable. X to the 5th times x to the 9. X to the 14. It becomes 14 over 3. 3 goes to 14 how many times? 4 times. And then you have a remainder. How many remainder? Or how much is the remainder? 2. So you have 2x's. What gets what? 2x, right? So, so the remainder has to go back inside the house. And then you combine them. How do you combine them at the end? Outside. 3x squared. Perfect. So you simplify them separately, but then combine. Any question? Was there anything confusing? No? Okay, now multiplying radicals. And instead of one term by one term, you're multiplying one term by 2 terms. So when you have one term, we actually call them monomial. Monomial means one term. And binomials means 2 terms. So in the last 2 examples, we did monomial times monomial. And now you're doing other different thing, monomial times binomial. But we know what to do, right, from our previous experience. How do you multiply monomial and binomial? Distribute. So you multiply the first term in the binomial, and then you multiply the second term in the binomial by our monomial. So we have square root of 6x. We take the first one, square root of 6, we multiply. Then we have a minus sign. So square root of 6x and multiply that square root of x. So take your 6x and distribute to both of them. Once you distribute, now we are going to do the same thing what we did before. You multiply their inside. So we have 6x and 6. But since we have two things, we are going to split them into two pieces. Square root and square root. Under one square root, we have x, that's the only variable. And under another one, we have 6 times 6, which is 6 square. Well, let me write my variable. So you're multiplying the inside, 6x times 6. But since we have two things, variable and number, so separate them. Minus. We have the same scenario in the next one. We have variable and number, so separate them. This time we have only one number, so we get 6 alone. And you have two variables, x times x squared. And now we simplify. What happens when you have square and square root at the same time? They kill one another. So see here. So you're left with 6 here with the square root of x. And for the number, we have square root of 6, and we have the variable alone. That's it. We cannot go any further, so leave it alone.
Can I put the x in front?
You can, but you don't have to because x is the variable. You can put x square root of 6, no
Put in
problem.
the front because it should be what comes out of the radical.
Yeah, but this time it's variable. We like to see variable on the right side. In multiplication, position doesn't matter actually. Any question? Easy, right? Not bad. So built on this, now we have binomial by binomial. Right? Doesn't matter what they give you. We have to do the same thing several times. That's the difference. We take the first monomial from the binomial and we distribute to our second binomial. So we have 4 square root of 2, and we are going to distribute that plus to 3 square root of 2 minus 4. So take the first monomial, multiply the binomial. And then, let me change the color. Take the second monomial and multiply the binomial. So second monomial is plus 7. And you're multiplying to the binomial 3 root 2 minus 4. So one term on the first, multiply entire second one. Then the second term on the first, multiply the entire second term. And now it becomes easy, just like the left page. Monomial times binomial, so you just do the multiplication. So we have 4 square root of, let me keep my color. We have 4 square root of 2 multiplied to 3 square root of 2. So distributing. And then we have this sign. We have 4 square root of 2, and you're multiplying the 4. Or if you want, if this makes you confused, then you write plus 4 square root of 2 minus 4, because our second term is minus 4. They're same anyway. Then we go to the second one. We take our 7, we multiply the 3 square root of 2. Then the second one, we have plus 7, and we multiply the negative 4. So multiply 1 by 1. You don't have to do that once you get used to it. But since I'm doing it for the first time, I'm showing all the details. And then we multiply. For each one of them, most of them, we have something outside the radical, something inside the radical. So when you multiply, you put the outside with the outside, inside with the inside. Ali, you're so late. What happened? Wow. Oh, man. So outside we have 4 and 3. We multiply, what do you get? 12. Inside the radical, we have 2 times 2. So instead of writing 4, since you're the exact same thing twice, you can use 2 square. Yes, you can multiply 2 times 2 is 4. But if you use a square, you can see they cancel out. Now, in the next one, we have positive 4 times negative 4 outside the radical. So what do you get this time? 16 outside the radical. And unfortunately, we have only one radical term. So we just bring it down. In the next one, we have 7 times 3. 21. And also you have only one radical term. So bring it down. If you have 2 radical terms, add them, multiply the inside. But if you have only one radical term, just bring it down. And lastly, we have no radicals. What do you get? Negative 28. So here, 12 radical and square cancel out. We get 12 times 2. What is 12 times 2? 24. And now when you observe this one, they both have the same radical 2. So when you have the same radical, same inside, same everything, you combine their coefficients and leave your radical with that. So the first square root of 2 has a coefficient negative 16. Second square root of 2 has a coefficient positive 21. So you combine negative 16 plus 21. How much you get? Plus 5. And you keep your radical term. You cannot make it disappear. You have to keep it with them. Just like variable. If you have negative 16x and positive 21x, the answer is 5x, right? So x is same as square root of 2. Any radical term is same as it's a variable. So when you add or subtract, it has to always come down with your coefficients. And the last thing, we have the lonely 28, so we bring it down. And now what do you observe on the last line? These are like terms. So we have to combine them. What do you get? 24 minus 28, negative 4. And we have 5 square root of 2. So this is our final answer. We cannot combine them anymore because 4 doesn't have any radical, square root of 2. So we'll leave them alone. Any question? So we multiplied monomial to binomial, binomial to binomial. And now we have binomial to binomial, but it's a special types of binomial. Before we do this question, let me ask you a few questions. If you multiply x plus y with x minus y, without using FOIL, do you know the answer? Without using FOIL. Does anybody know the answer? What's the products? Without multiplying them. Do you know the answer? Nobody knows the answer?
Squared minus y squared.
Good job. X squared minus y squared. You can verify that using your FOIL method. But you don't have to use FOIL because when you add or when you have same two terms, adding and subtracting, and you're multiplying them, the result is the individual squares and minus between them. We call them difference of perfect squares. When you have the exact same two things, but their signs are different, we call them conjugate. Conjugate. And when you multiply any to conjugate, the result is the first term square minus the second term square. Can you guess the answer for a plus b times a minus b? A square minus b square. How about p plus q times p minus q? P square minus q square. How about m plus n times m minus n? M square minus n square. So without using any foiling method, without doing any work, we can easily find the product. It's the both of their squares and minus between them. So here we have square root of 13, exact same square root of 13 on both binomial, and exact 2 on both binomial. So square root of 13 plus 2, square root of 13 minus 2. We have a conjugate pair. Conjugate. That means we didn't have to use the method we did on the left page. When you don't have conjugate, you have to do manual multiplication. But for conjugate, what's the result for the conjugate? Square root of 13 square minus 2 square. So you take individual term and you square them. And you always subtract them, always. Never add them, always subtract them. We call it difference of perfect squares. And now we just have to simplify. Radical and square root and square cancel out. What do you get? 13. And you're subtracting how much? So what is 13 minus 4? 9. See? We didn't have to do much math. Even if you do it mentally, we get 13 minus 4, 9. We don't need to do all the details. However, if you forget it's minus first one minus second, first one square minus second one square, use the foiling method. It will take time, but no problem. Okay, now still is multiplication, but this time it doesn't look so cute. It looks horrible. We have fractions. But doesn't matter. The same rule apply. Distribute. So we take our monomial and we multiply the first term. So we have x to the 3/5 times x to the negative 1/3. Then you take the second term and you multiply with the second term. So plus, let me put minus. I don't want to waste my time. X to the 3/5 times x squared. To distribute step 1. And you know the step 2 now, because we did a few examples already. What is our next step? Next step. In multiplication, what do you do with the powers? So what is our next step? X to the 3/5 plus the negative 1/3. So we get x to the 3/5 minus 1/3, because we're adding this to power. Similarly, you also have to add this to power. So minus x to the 3/5 plus 2. For the first one, do you have the same denominator? So we need to have the same denominator. What is our same denominator? 15. So we want to have 15. So we need to multiply 5 by 3 and 3 by 5. So what do you have on the numerators? 9 minus 5. What do you have? 4. Then you go to the next one. This one, if you don't want, you don't have to put you don't have to put the same denominator. You have a shortcut. You can multiply the denominator with the number, and then you combine the top. Yes, you can use the same denominator, but it's a shortcut. Multiply, add. So 5 times 2 is 10. 10 plus 3 is 13. So it's 13 over 5. If you don't understand, then you can use the following method. We want 5 by 5, so we have 5 times 2, 10 plus 3, 15. And now we can't do anything because it's subtraction. If it was addition or multiplication, so if it was multiplication or division, we could do more. But for addition or subtraction, we have nothing to do. We can rewrite as an exponent form. Not exponent, radical form. Like 15th root of x to the 4 minus 5 root of x to the 13. But you cannot combine them in you. For what? Why? But you're subtracting variables. In multiplication, you add the variables. But here you're subtracting the variables themselves. So we have nothing to do here. All those power rules, the exponent rules, they're only for multiplication and division. For addition and subtraction, there is no rule. So stop. And now the last question before you do your practice questions. It says factor x to the negative 1/5 from here. So they gave us factor, they told us multiply in the last example. And this example, they gave us the answer. They're telling us factor that. But before we do this horrible looking factor, let's do some easy factoring. Can I flip my page, guys? Okay. Let's see, have x squared minus 3x. Factor. What are you going to factor? What's the common factor between x squared minus 3x? Factor. Come on. X. Once you factor out the factor x, what is left? X minus. Right? How do we know we have x left here? How do you know that? So what happens? You have square, you factor the x out. So what did you do? You divided, because in division we subtract the powers. So you left with x. We had 3x. How do you know the answer is 3 once you take out the x? Why 3 is left? Because when you factor the x out, you're actually dividing the 3x by 3. So you left with 3. In other words, we don't know, but mentally our brain is so smart, it does all the math automatically. When you factor out something, you divide everything to see the remaining parts. Did you even realize that? See, you told me the answer right away, but how do you come up with the answer? You have so smart brain. Let's do one more example. Let's say we have x cubed minus xy. What's the common factor now? X. So what is left? X squared minus y. How do you know? Because your math did the invisible math. You had x cubed. Once you factor out the x, it means you're dividing by x. So in division, you subtract the power, you're left with x squared. Similarly, you had xy, you factor out the x, your brain did the invisible division for you. You get y left, and you told me you have a y. See? Even if you don't know, your brain does. So trust in your brain. The same concept we are going to do here. They told us factor out x to the 1/5. So we know what to factor out, x to the 1/5. So you have 2x to the negative 1/5. And once you factor out x to the 1/5, means you're dividing by x to the 1/5. So what do you have? Sorry, they told us to factor out x to the negative 1/2. Sorry, my bad. So what do you notice? You have 2 because you have the same thing division. So you left it 2 in the first term. Minus. In the next term, you have 7x to the 4/5, and you're dividing by x to the negative 1/5. So what do? We have a negative power we dislike, so we have to bring it up to make it positive. So 7x to the 4/5 times x to the positive 1/5 from the denominator. And in multiplication, what do you do with the powers? Add them. So we have 7x to the 4/5 plus 1/5. So we have 5/5, basically 1. So we have 7 with x to the 1 power. In other words, we have only 7x. You don't have to put bracket, you can put parentheses. And that's all you have to do.
What if it doesn't add up to 1?
You keep it. You keep your whatever the answer you have.
It's like 2. How would it be in the equation?
2
So 7x
square.
squared.
Any question? Now let me tell you the good news. These two types are horrible looking, so they will not be in the exam. But the bad news, they're in the homework and quiz. So you're going to do them in my math lab, but you don't have to know them for the exam. Any question from anyone? Any comments? Yes, I'm recording. Any question, comments, concern? No? Then enjoy. I have 1, 2, 3, 4, 5 questions for you. And you have 15, 20 minutes. And again, I did all of them with my morning class. So you can watch the solution in my morning class. Brennan, no phone. I want you to pass this class successfully.
Yes.
Okay, guys, enjoy. You can talk to your neighbors. And if you want, you can use AI to understand the steps, not to copy the solution. I will do that. Who needs help? So far from me. Can you come here, please? Thank you. So it goes to break them down. So 3 is what times what? And I was 18. Yeah. But you're looking for one number 3 times. Do you see the same number 3 times? No. That means you have to break it down. But now do you see the same number 3 times? Yeah. What's good? You put the multiplication inside. Any other person need help? Who is confident about all of them? You're not factoring and multiplying this time. With binomial times binomial. Who is done with everything? George, right? Anyone else? Let me see your work, George. I think okay. 1, 3, 1, 4, 8. Right. This one. Perfect. We broke it down to 2 pieces and then combine this and then multiply it. And then here you have 5 and 1. Perfect. Now here you have 27 star and we have 10 7. Negative 12 7 and this. So this gives you negative 7. You don't have enough weight. And we have 5 squared 17. So multiplication gives you 0. So you have 1. Wow, it's all. And then you have 3, 1 half. But this is negative 1 half, right? That means you cannot combine them. Here's negative 1 half. One of them is negative 1 half. It's not. So we have to do negative 1 half. This is negative 1 half. And so this is 6 and 1. Yep. So good job. You help? Yep. Who needs help? Anyone? Don't be shy, I'm here for you. Thank you. You mind if your name again? Jalissa. Yeah, that's like so then we find since the next one. Go ahead. Right, yeah. 1 and 3. So please 1 and 3.
4 times, right?
But you're going to see the same number how many times? So do you see the same number 3 times? It means you have to keep breaking down. So 2.3 seconds break down more.
We're just calling for it's 20.
Now do you see the same number three times? And what is extra? So multiply them with hours. So these three goes together and keep power inside one of the dots. And 2 times 1 goes inside another of the dots. You get me. So you are the same. What do you think this like? No, we just simply cancel one out. The goals to cancel them. That's how we put it. And then when you combine 3 with 3, inside of this.
Just like I said,
That's 3
on the side of this. So it's.
and then inside real. Inside the really felt. Anyone else need help? I'm here for you guys. Almost right. The only problem is we have one negative 1/2 plus positive 1/2. In multiplication, we add the powers, right? So you have they cancel out. Cancel out means you have extra 0. What is extra 0? Go back to your go back to the 0 and 1 rule. What is anything not 0 to the power 0?
So this gets.
So this term becomes 1. We can combine this 1 with a negative. And yet this is because they have nothing in common. But they are not 1, they are not negative 1, they are negative 1 and positive 1.
Would that do it?
And but then it's going to be down like that, so they become positive 1.
And then you would do like the X, right?
Yeah, and then
4 times 4 is not 18, 4 times 4 is 16.
7 times.
Yes. 4 times 4 is not 18, so it's 16. You have to find another 2 numbers.
Oh, like this side.
And then you have to keep breaking it down until you see to the same number.
Okay, that makes a lot more sense. I got it.
7 plus
7.
7 plus.
Need help? Anyone?
Yeah,
Don't forget.
And also, George, the negative power you have to bring it to the denominator to make it positive. For the negative 1/2 power, it cannot have a negative 1 to make it denominator to make it positive 1/2 power. The last question we discussed. So you have to make fractions of it.
Why didn't we use this?
We're gonna come back to it right now.
Anybody needs help? So for next week, Tuesday, your homework I forgot to mention. So we are done at 10.2. Homework for Tuesday midnight and quiz is 5.1 and 10.2.
So then, so do homework, is picture.
Homework and quiz. Depending on your quiz, I forgot which quiz you have. You have one quiz on 8.1, 8.2.
It was due to this Tuesday, yeah.
And then you had another one 3.6 alone, right? No, 3.6 and 5.1. Oh yeah, the second quiz, I remember. Quiz 2 was 3.6, 5.1. So you have to do quiz 2. 2 homework, 2 quizzes. And quiz 3 is 10.2. 10.2 has 1 quiz. 5.1 is combined with 3.6 as 1 quiz. If I'm not wrong.
Two quizzes are due next Tuesday.
Tuesday midnight and also the homework 5.1, 10.2. So 2 homework, 2 quizzes. And if you miss the deadline, I open them so you can still do them till Tuesday. Bye, guys. Keep an eye on Bright Face. I'm going to post the review sheet. Be safe. Don't get sick because there is no makeup for the exam.
So I was watching your video. I did all this, but I couldn't say I did 25. So
It's you don't have. It's for the next math.
oh, it's for the okay.
The next math that you have space, I did on the.
Oh, okay. Thank you.
I activated Math Lab a couple days ago, and I can't do the other assignment.
You can. I think I opened them. Try it again.
Okay.
And if you cannot, shoot me an email.
Oh, thank you.
Even though it says date over, but I allowed the late submission.
Okay.
So you can still do that.
I'll send you an email. Thank
If
you.
you cannot, send me an email.
Thank you, Professor.
Oh, you sent me an email, right?
I did, but also.
And they're open, but I forgot to email you back.
I was gonna check today and see if it's open.
Yeah, they're open.
Yeah.
It says due date is over, but I still made them available for late submission.
Yeah.
So you can still do them, but if you cannot,